All right, so this is a system diagram that I made for the second time I did You're a Good Man, Charlie Brown. I think, yes, this was the second time. I've done that show 3 times now. And you should be pretty familiar with this kind of drawing now, right? These are just system diagrams. You've done a few of these now. And this is really helpful document to kind of figure out how this sound system goes together and how the signal flows through it and all of that. This is a really great place to start. But there's a lot of a very important information about this sound system that is just not contained in this drawing. And that is all of the connections. So I don't know what your experience has been so far with this, but in my experience, when you've got a sound system and it's not behaving the way you want it to behave, and you've eliminated, just the stupid mistakes that you could make, right? I mean, at this stage, that's pretty likely, right? You're probably going to make some just mistakes. And but once you've eliminated that and things are still sort of like not behaving and not doing what they want, most of the time it's because a cable is messed up, right? And it's messed up because it's either connected to the wrong thing or the cable is broken, right? It's cut or nicked, or the connection is bad inside the connector, the solder joint or something is bad, or there's any number of ways. There's just a lot of ways that cables and connectors can get messed up. It is the cables and the connectors are, I would argue, the most volatile part of your sound system. They are the thing that is the most likely to break, the most likely to be messed up, and the easiest thing to harm. And the real bummer to all of that is that is also the thing you have the most of. So the thing that you have the most of is the thing that is the most likely to, be broken. And that is a very significant challenge that we face on a daily basis. One of the things you'll learn, I think, next fall, this group will take the audio electronics class with me. Is we're going to learn where cables come from, and the good kind come from you, because if you make your own cables, then you know what is inside of them, and you know how well you can trust them, and you understand why a good cable is so valuable. So anyway, we'll learn about that. But given that the cables and connectors are the things you have the most of, and they are the things that are the most likely to be broken, it would sure be nice if you knew where they all were. This can also bite you when you don't try to figure that out ahead of time, and you go and get your gear from a shop, you load it all up, you take it across town to the theater, and then you realize, oh crap, there's like 30 cables or something that there's 5 adapters I didn't realize I needed, or this has the wrong connector on it, or I forgot that I needed this, and it's usually connectors and cables. And most of the time, when you all have to go back to the shop after you've left the shop, it's for cables. Because you didn't figure all that out ahead of time, and sometimes it's tough. That happened, I think, on Mother Courage last week. They went in, I guess it was Wednesday, they finally went over to the space, and of course found out that there was a number of cables that they didn't have and forgot to bring or whatever, and the next time they could get into the shop was Thursday afternoon. So there was a 24-hour period of time when there was certain work they were prepared to do, but they just couldn't get done because they didn't have what they needed, right? And so that can be very frustrating, and that's completely normal when that happens. So today I'm going to teach you how to do a patch plot, and the patch plot is designed to address all of these problems that I've just talked about. A patch plot will help you figure out where all the connectors are. It will help you figure out what cables and adapters you need so that you have them all and you don't forget any. And then it can also help you once the system is put up. Like if you are having a hard time with the system, it's not behaving the way you want, and you don't understand why, and let's say you eventually pluck up the courage to ask me for help, I'm going to come over, and one of the first things I'm going to ask for is, well, let's take a look at your patch plot, because I'm going to need that as we go through this thing. Because when I troubleshoot something with you, the first thing I do is I go connector to connector through the entire signal path of the thing that's not working. And we check for the functionality at every connector, very methodically, until we find the connector that is not delivering sound, and then you know approximately where the problem has occurred. And so I use the patch plot as a troubleshooting tool because the patch plot theoretically has told you where all those connectors are, and those are the things that are most likely to be wrong and or broken. So how do you do this? Well, the first thing I want to say is everything I'm about to show you, I made this up. Okay? So you're not gonna, you will see versions of this kind of thing here and there, but there's no real standard for this. And so you're not gonna find this in a book, unless it's my book. You're not gonna find it on YouTube unless it's my YouTube page. And there's probably going to be, you show this to some other people and they're probably going to laugh at you and think you're so crazy, why are you doing this? Because it is a lot. But here is a patch plot for that system diagram. And it just goes to connector through the whole system until I figure out what's going on. So let me show you how this is accomplished. So I do this in Excel. It is possible to do, I know that a lot of you are like Google Sheets people, and I understand why, because that's the thing that you learned in school and stuff. And Google Sheets is fine. But there is one very important thing that it is terrible at. And it is terrible at laying something out that will eventually result in something that could look like a piece of paper. Its layout tools are really, really not very good. If all of that document ever needs to be is in digital form on a computer screen on Google Doc website, then fine. But trying to go from a Google Doc to a PDF that's laid out professionally and looks nice is very difficult in Google Docs. Numbers, some people like Numbers, which is Apple's spreadsheet. Numbers is really is like the opposite. Numbers is insanely good at creating really nice looking layouts. But because that's what it seems to prioritize, it makes getting to the data side of it a little more cumbersome, it seems like, because you have to build the structure around which you can put the data, which is fine, and if you can deal with that workflow, that's fine. The other issue with Numbers is there's compatibility issues. Obviously, it's nowhere near as common. It's not cross-platform. There's issues. That being said, I don't really care what you do these end. I just care that it looks in the end like what it's supposed to look like, okay, and then that it's right. But I am going to show you how to do it in Excel, okay, because I think that is the superior tool. So the first thing I'm going to do is I'm just going to go in here and zoom in to like 200% so you can see what's going on here. So if I look at the system diagram, let's start with these wireless mics, okay? All right, so I have a microphone called a Countryman E6i. All right, so I'm going to just type that in a cell here. Now, here's a little trick. You watching? You see how the text is bigger than that cell? If you hover over this little divider between the two column headers and double click on that, it will automatically resize that column to fit that text. Okay, there's a little tip. Okay, Countryman E6i. The Countryman E6 is going to have a connector on the end of it. And in this case, it's plugging into a Shure ULX transmitter, so I know that it is going to be a TA4 it'll be socket connection. So on the end of the cable. So you can do TA4S. The patch plot example that's in there, just because I made this, I don't know, 12 years ago or something for a show I was doing, is still using male-female for the connectors, because that's what we were doing then. But generally speaking, we're trying to, we've realized that's kind of silly. So there's a pretty big push right now amongst the sound professionals to sort of use less ridiculous terminology. So the one that tends to be landing with most people is pin and socket. So S would mean socket, okay? Now, so Countryman E6i into a TA4 socket connector. Now, you don't need to know that off the top of your head. I know that off the top of my head just because I do, but you don't necessarily, I'm not expecting you to know those things. When you do these in real life, you will need to go and look at that. You will need to go and look at that microphone and be like, what is this connector? So that you can put it in your patch plot. And that's the point. The point of the patch plot is it forces you to find those answers that you don't have. Like, you have to put an accurate thing in there, and if you don't know what it is, then you need to go figure out what it is so that you can put it in here so that you know you get the right thing, okay? So I know it off the top of my head, but that's not, you probably won't be there yet. A TA4 socket connector is going to connect to a TA4 pin connector. Okay? Because that's how connectors work. Connectors touch connectors. If you ever have a cell on your patch plot that is just a connector that doesn't have another connector right next to it, you have done something wrong. You have missed something. Okay? Because that's how connectors work. And that TA4 pin connector is going to be on a Shure ULX I believe it's a ULX2. Pretty sure. Let's go check real quick. Well, we need the old analog ones that they don't make anymore. Are they not on here?
If it's the body type, it's the ULX1.
Probably, yeah.
2 is the handheld.
That's right.
4 is the receiver.
That's right. So this is going to be a ULX1 transmitter. Okay, now in this case with this Countryman E6, I don't know what did I do on the?
You just started.
Oh yeah, I just started at the mic. So that's fine too. But this is a piece of equipment, okay? And in the rules that I made up, pieces of equipment are shaded in the color of gray, okay? The point of the colors is just to break this up a little bit to make it easier to read, okay? So the colors are important only in that they help this to make some sense, and not just be a spreadsheet of just cells with data that is hard to kind of wrap your head around. But using the colors helps that. Well, a ULX1 is also a piece of equipment, okay? And then, you know, there's some air here, okay? Because this is a wireless transmitter. So I would just make a cell called wireless. That is, wireless is not equipment, and therefore I would not fill that with a color. But it is going to hopefully go into a ULX-S receiver. And on this ULX1, you could even say transmitter if you really wanted to. So there's a ULX-S receiver, and that is going to have an XLR pin connector on the back of it, which is then going to connect into my mixing console. So there's going to be a cable involved there. Because remember, connectors touch connectors. So I'm going to also have an XLR socket connector on the end of some sort of cable going to an XLR pin connector. And that XLR pin connector would connect to an XLR socket connector. And that XLR socket connector would have a label on it. And that label would be input 27. And that label would be on a thing called a Yamaha LS9 32 mixing console. Now, the cable is not a piece of equipment, so that is not going to be gray. So I'll go ahead and get rid of that. And I'm going to end up with a bunch of stuff here. So let me show you that we start at 27, and with those wireless mics, we go all the way to 32, it looks like. I'm going to show you a trick. Are you ready? If the label that is in this cell ends with a number, then you can hover your mouse over this bottom right corner and see how it turns into, that little crosshair turns solid. You can click and drag that, and it will automatically increment those labels. I go to 31, is that right? 32, what did I say? I think it was 32. Yes, 32. So see, if I just click and drag that down, I get all those labels. Now watch this. I can do the same thing with that whole thing. I don't have to type all of that in. I just selected that whole row and went boom, drop that down. It's all the same. That work? Now the other thing I will often like to do is make the actual names of things bold names of equipment and stuff. Again, just to kind of like help things to pop a little bit. So that'll be bold. That can be bold. And eventually this LS9 is going to be pretty big. I'm going to have a lot of things connected into it. So I'm going to go ahead, select this top cell. Now watch carefully. I'm going to just come down to some arbitrary length here for now, and I'm going to click while I'm holding the shift key. And it will select all of that. And then I'm going to click this button that says Merge and Center. And that's going to turn that all into one cell, okay? And then here in the alignment, text alignment thing, that you've got left, center, right justification, but you also have top, middle, bottom. And I'm going to put this into middle. Okay. Now, if there is a cable that you could hold the entirety of it in your hand and leave the building with it. Like if that's possible, it's possible for that cable without, the use of power tools or something. If it's possible for you to pick that cable up and walk out of the building with it, then that means that it is possible that that cable may not be there unless you bring it. Okay? Because some cables, it is not possible to pick them up and walk out of the building because they are run inside of conduit. Or one end of them is hard terminated into some sort of conduit. And you're not going to be able to walk out of the building with that cable. But if you can walk out of the building with it, then you really want to make the name of those cables red, the text, and bold. So it jumps out on the page at you and says, hey, heads up, you have to bring this. You must bring this cable, or you cannot guarantee that it will be there. So that's what a red label means. A red label means this cable is not part of the building, and therefore you must bring it, or at least make sure it's there, because it is possible for it to not be there. How are we doing so far? Everybody keeping up? Making sense? Okay. So this is the basic idea. Now, what I want to do now is just kind of show you where I landed on this thing. Actually, it's here. So I did the whole thing, and here it is. Now, it turns out, in real life, what I did was I did not just do individual XLR cables for those ULX receivers. I actually did a snake. And a snake is a special kind of cable that has lots of cables inside of it. Okay? And so it's like one big thick cable that on each end kind of fans out to multiple cables that have connectors on them. So that's what I ended up doing, is I ended up doing two snakes. One for the band mics and one for the wireless mics. And it just makes things a little bit simpler. And so, but because both of those are snakes, those are cables that could leave the building. Like I could walk out of the building with that snake if I wanted to. I put them in red. But because it's a snake, I shaded them with the color yellow. Yellow means snake. Special cable, right? There's no reason for any of these colors. I made them up, so don't ask. It's just, and if you don't like these colors, that's fine. You're allowed to not like them. But the only reason the colors mean anything at all is if we all agree that they mean something, okay? If we all go and just make up our own color schemes, then we can't read each other's drawings and know what they mean, okay? So you cannot like these colors, and that's okay, but you still have to use them. Because if you don't use them, then they lose all their meaning, okay? And if we want to have some sort of, summit where we can negotiate new color schemes someday, like we can do that, but We just all have to agree. By the way, it was Jared Bowman and I that made this up. When Jared was in a class with me several years ago, I said, Jared, we got to figure this out. And so he was there. He can vouch for the fact that we totally made this up. Okay, so here's an example of a different kind of an adapter cable, right? Where I'm doing a 1/4-inch tip sleeve to XLR. It's still a cable, and I just put the name of the connector on each end with the red cable in the middle because I know I have to bring it. Okay. Let's see if I can show you a couple other things. Okay, so here's an example of a snake that on one end has what I would call tails, and tails is like the fan out where you've got individual connectors for each cable inside of it. But the end of that snake is a single connector that has a whole bunch of pins in it, and that's common in like installed sound situations. It's meant to make things easier for you, but it ends up not making it easier, in my experience, because it's so easy to mess up those multi-pin connectors. But that's what they had. So, and they had an multi-pin extension cable, and anyway. All right. Now, this works better. So you see these blue things. Well, blue represents a patch bay. And what a patch bay is when you see a connector on a wall somewhere with a wall plate, you plug into it like an XLR. Well, there is some cable on the other end of that connector, like that's running inside the wall. Okay, and it's no more complicated than that. It's just a cable that someone has already run for you. It just happens to be run inside of a wall instead of gaff taped to death, along the base of the wall, which I don't know why y'all are like so excited about your gaff tape. It's like it's like, I don't know. We'll burn up $20 in gaff tape, just like slathering tape over these things. It's not necessary, but that's another little soapbox I have. But anyway, in the case of installed wiring, it's just inside the wall, which means that connector, the other end of it is somewhere, right? I mean, you plug into that wall, that connector on that wall, somewhere there's the other end of that cable. And generally speaking, on installed theater situations, all of those go back to the same place. So the one end of them will be each scattered all over the building, okay? But the other end of them will all end up in the same spot, and it'll be just this little rack that is full of connectors that have labels on them that represent the other ends of all of those cables that go all over the building. And that's called a patch bay. And you connect a signal from one side of the building to a signal on the other side of the building using a patch cable. So you would just go and from one connector to another connector inside that rack, and it would connect those two things together in the wall. That's called a patch bay. And so if these connectors and the labels on them are part of a patch bay, you want to shade those in blue just to make that clear for yourself that, okay, that's a patch bay. And in this case, I've got a patch cable that I'm using to patch between those things. Everybody with me so far? Now, one thing to notice, here's another patch bay. Okay, this is an NL4 patch bay. And the other side of that connector on that patch bay shows up at a wall somewhere. And if it is a connector that is on a wall plate, you want to shade that in some sort of, I call this lavender, because it's not purple. Purple is a little bit darker than that, I think. So it's just a light shade of purple. And that indicates, hey, that's a wall plate. That connector is stuck to a wall. Okay? Which is important for you to understand that, because it means that it's going to be very hard for that connector to not be there. Okay? Let me see. Is there anything else, as I pan through this, is there anything else I have not explained? convention here I've not explained. Oh, house wire. So house wire is, cable that is inside the conduit in a wall. You need to know that it's there because it's part of your system, but it's not something that you can touch, at least not without an enormous amount of effort and probably power tools. You're not going to be able to touch that wire, okay? But you do need to know it's there. So I do have a cell for those, and I just call it house wire. House wire just means it's part of the house. It's in the building. It's probably always going to be there until we decide to renovate or something. So that's what house wire means. It's in the rack, in the wall, something like that. Not something you have to bring. Okay, I think that's all of it. So remember, connectors touch connectors. Connectors typically have labels. So you're almost always, unless it's just a regular generic patch cable, but if it's a connector on a piece of equipment, it's almost always going to have a label. And you want to have that label, you want to have a cell for that label right next to that connector. Okay? So the other thing I have done is I have gone in and I have turned on the grid lines. And you do that by just selecting an area here, and over here I'm going to say all borders. And that helps when you plot this to tell the difference between cells, okay? Because when you plot this to paper, all these little thin gray lines don't get printed as part of that, okay? So here's the full thing. I just went through and did the whole thing, okay? If you find yourself in trouble where you ran out of room or something, like maybe I realized, oh, I forgot, I gotta put something here in the front. You just right-click on this cell, or on this column here, it's like here, and insert, and it'll give you another one. It'll just shift everything over. Okay? And maybe you realize you need something up above this first line. Okay, great. Just select that row and do insert, and it'll knock it all down for you and make you some room. Okay? But eventually, you will end up with something that looks like this. Well, this is going to be tough to make fit on anything that could resemble a piece of paper. Because by the time you get it, even just to fit in this screen, it's tiny. There you go. It fits. You can totally read that. So this is not a super great strategy. So let me show you, and this is where Excel becomes really useful to you as opposed to something like Google Sheets, okay? So what you're going to do, when it comes time to lay this out for something that might look like a piece of paper, you're going to right-click on this tab that you've built this all in, and you are going to select Move or Copy. And you are going to check this box that says Create a Copy. And I'm just going to click this box that says Move to the End. I'm just going to make a copy of it at the end of the list here. So I'm going to call this Layout Demo. What you're going to do is you're going to first go to the File menu and go to Page Setup. And you are going to make sure that typically landscape is the way to go here. And it is possible to just tell Excel to squish this all down to a piece of paper, but that is not what you want to do. Stick to this 100%. Make sure this says 100%. Okay? If you want to, you can actually go in here and put headers and footers on this thing to sort of like a title block-ish kind of thing, if you want to. But the big thing you want to do is this thing called print area. So you want to define the area of this thing that is going to be printed, which in this case looks like, oops. Ah, it's not bad. Why is this mouse freaking out on me? I'm just going to go and select everything and then hit enter. And there's my print area. And I say OK. So now Excel knows where I'm going to print. And then I want to go into the print dialog. Oh, they changed how this looks. Holy moly. OK. Under paper size, you want to do tabloid, 11 by 17. That's probably the one that's going to work the best for you. And once you have that, I don't know if you can see it, but there are these dotted lines that have shown up. You see right there, that dotted line? Is that rendering up there at all? Kinda. Here on the side of this cell W, this column W, see that dotted line? That is the end of the page. Okay, that's where Excel is saying, hey, I'm going to run out of paper here, which means after this, I'm going to jump to a new sheet of paper. So Excel will try to do this for you, but the problem is, you don't necessarily need a whole separate piece of paper because there's going to be a lot of blank space, on this page. If you go into the print dialog and look at how this is, you can see what it's going to do. There's all of this blank space here that is not helpful. So instead, what you want to do is, now that you understand where the end of the page is, you can now move stuff. So what you're going to do is you're going to try to find a place where it makes sense to divide this. And I think I did it here. You want to divide it in a place where you're not going to be confused as to where this jumps. And I will explain this in a minute. So I'm going to take this. These cells will be the end of this particular row. So I'm going to select them, and I'm going to go ahead and select everything after that. Let's see, please let me. Come on. Let me zoom out here. It's just not letting me because I'm hitting the edge here. So I'm going to shift click over to here to extend that selection. Once I've got it all, looks like I do, I'm going to do copy or Command C. And I'm going to come down here, one or two cells below the lowest thing, and I'm going to paste it. Okay? And now I'm going to go in and I'm going to come up here and I'm going to delete everything except that first set of cells that was part of that copy. I'm going to leave the first part. I'm going to go in and get rid of the rest of it. Okay? And you just do that by selecting it and then right-click and say Clear Contents. And you can even go in and clear out all the shading to say no fill. And you can say no borders either. And that gets rid of it all. And then it probably, in this case, like removed that border there, so you can put that one back in. Okay? So now let's see. So now I've messed up my print area. Oh no, there it is. Okay, there's the dotted line. Really got to zoom in to see it. See, there's the dotted line right there. So I got to find a different spot now to break it. Yeah.
You might be getting good. What about the fact that now it like changed all the sizes of all your boxes?
Yeah, we'll get there.
Okay.
Yep.
Okay.
It will do that. So I got to figure out a new place to break it that makes some sense. What you don't want to do is break it somewhere like here, because it just has generic connector labels on there. And you may not be able to know exactly where you need to pick up when you left off. So you want to try to find something that's unique. So the nearest thing that looks like it is totally unique without going outside of the print area is probably this to system cell. That's going to be pretty unambiguous as to where it's going. So I'm going to break it there now. Let's see if is that where I broke it on this too. Hey, it is. Look at that. Okay. So let's go in here and get everything else. And I'm going to copy that. And then come down here. Again, a couple of cells below. And paste. And then I'll go in and get rid of everything after that first thing again. Clear. And no shading, no grid lines. And then I'll add the grid lines back in here. Okay. Let's now see where we are. I must be pretty darn close here. I'm going to redefine my print area. So I can force it to tell me where the lines are again. So you just select that and you can just go straight to print area and say set print area. And, oh, there it is. There is the magic dotted line right here. Okay. So where do I want to break this? I think the most logical place would be here. So that's going to be pretty clear what that is when I repeat it on the other line. So I'll go in, I'll get all of this. I will copy. And then I will paste. Oh, this is going to work great. Okay, so now I'll go here and we will clear this. Get rid of the shading. Get rid of the borders, redefine the borders here. Okay, so now I know for sure this is going to fit on that 11 by 17 piece of paper. So I'm going to go ahead and remove these rows that I don't need. And then I'm going to go in and select this area here all the way over to where the dotted line is. And I'm going to put a border, this thick bottom border. Because I just want it to be very clear that I'm starting a new spot here. I'll do the same thing over here, all the way to the end. Bottom border, same thing here, all the way to the end, bottom border. And now, yes, I have to resize everything to make it fit. So basically what you're going to do is you're just going to go in and double click each of these columns to resize them appropriately so that it's not cutting anything off. And having done that, you see now that I'm just outside of my dotted line, but that's fine, because I now know that it's going to more or less fit, which means if I wanted to, I could actually just print this straight to a piece of paper now, and I could just tell it to fit to 1 page by 1 page, and it's not going to have to shrink it an enormous amount to make that work. So I can just go in and say, all right, here's my new print area. Oops, my mouse is really giving me a hard time. So I'll define this. We will set print area. Okay, and now I can go to print, and I will say scale to fit, 1 page by 1 page. And here I'm going to save this as a PDF. Okay. I could print it out to the printer, and we could see what that's going to look like. Let's do that real quick. Just see, is this going to be readable? Oh yeah. See? Look. Yeah. Yeah. Totally works. Okay. Now, what you're going to do is, well, I'll show you in a minute how to lay it out into your CAD layout, but I would suggest when you get ready, if you're the A1 on the show and you're getting ready to go into a load-in, I would suggest printing out a few copies of this. And if you want, you can even get out your scissors and cut out sections of it and like literally tape it to the racks that it applies to, right? It warms my heart when I see that, because like literally cut out this part that you know is in the amp room and just tape it to the wall of the amp room. Be like, this is what the amp room should look like if it's right. And that way, when you send somebody up there to figure it out, or you send me up there to help you figure it out, I can just go, what's this supposed to be like? And it's like, oh, it's supposed to be like this. Is that how this is, right? Highly recommended, okay? All right, so you've got your, let me go ahead and save my PDF now. So I do save as a PDF. It says, great, where do you want to put it? I will put it there. Now, let's go back to AutoCAD. So here's the system diagram. And I'm going to go into a layout here. Actually, I don't think this is the one I want to do. I want to do it here. Yeah. Okay, so this is what it's going to look like in a minute here. So I'm going to make a tab here. Call this the patch plot. Layout. I'm going to right click on this and set up a page size. And I'm going to go ahead and insert my title block. Come on. I'm running out of screen. We'll get that where we want it. And then I'm going to get rid of this viewport because I don't need it. And what I'm going to do instead is insert a PDF underlay. Now the idea behind a PDF underlay is like sometimes people give you a PDF file of that's CAD. And sometimes, depending on how they made it, you could actually import that and extract the vector line data and get more or less a CAD drawing out of that. But that's a relatively new feature in the last few years where they've made that. But PDF underlay or a raster underlay sometimes too is something that would happen. A lot of times you'll get like, if you ever go and work for a consulting firm, which odds are pretty good, one of you will. A lot of the work you're going to do, some of it's going to be new stuff, like new buildings, and some of it's going to be old buildings that are getting redone. And an old building that's getting redone is going to have old drawings that are probably not going to be in CAD. They're going to like literally give you rolls of paper. And you're going to have to scan those. And what you can do is you can do this in model space too. You can do a PDF underlay, lay it out there in the model space, and you can literally trace it in CAD to get the CAD file. And like, if you end up working in consulting, you will do that. Like, that will be your job when you start out, because like, it's annoying. No one wants to do it, so they're going to give it to whoever's the newest and least senior. They're going to, you're the one who has to trace the draft, you know. So it happens all the time. So get ready. That's what it's for, but we can use it for this too. So I'm going to say PDF underlay, and let's see. There is my patch plot PDF, and it says, okay, here it is. Now, one of the things I want you to notice is this is not putting the PDF into your CAD file. It is simply placing a little piece of data that links to the PDF file that is somewhere on your computer. Which means if you move this DWG file to another computer and you don't move the PDF file with it, this picture will not be there when you open that CAD file. Okay? So a good way to wrangle this is to just put the PDF file in the same folder as the DWG file and then move the folders around. Okay? Which is what I'm going to do using the one that already exists. So I'm going to go to the folder where this thing lives. There it is. Open that, and this is in the same directory, the same folder as my CAD file. And if I move the folder, then it should be okay. And I'm going to attach it, and it says, okay, where do you want to put it? I'm going to start it there, and then it's going to say, all right, scale it. How big do you want it? And I'm just going to kind of scale it to fit inside of there, and there it goes. You could now plot that out to PDF with every other drawing on your show, and it would all look like the same with your title block and all that, if that's important to you. Okay. Questions? So let's take a look at what you're going to do. You're going to do that patch plot. Okay? So I've got the actual plotted version of it with the title block here. So you can download that and look at it. And you're gonna do this in Excel. Because at this point, I don't need you to figure out the system yet. I just need you to understand how to make this in Excel. Okay? The point here is, can I make Excel do these things? And then later, when you're on a real show and you have to figure this out for real, that's when you'll figure it out. That's when you'll go through and go, what kind of connector is on the back of that thing? That's a big reason, by the way, why we make you leave your system set up in the shop after your final shop look. We typically give you about a week between your final shop look and your final paperwork look, because we want to give you a week to make all the paperwork, to document what you built in the shop. And you want to be able to like go in there when you're not sure. When you're like, well, what kind of connector was on that? I don't remember. You can go in and look at it and see how that goes together. And lay that all out in a patch plot, and then you go over to the space, the theater, and you figure out, okay, well, what is different? You know, there's going to be some wiring and walls I'm going to have to include as part of this, and how do I put that in here? It becomes a bit of a slow process that you have to like go through that. But here's the thing: you're going to have to figure that out eventually. There is no universe where you do not have to figure that out. Okay, you are gonna have to figure out where all the connectors are, how they all go together, make sure you have all the right adapters, understand how the patch bays go, which wall plates you're gonna use. You will have to figure that out. It is so much easier to figure, if you figure that out before you try to do the load-in. If you're trying to figure that out while you're doing the load-in and you've got a crew of 3 or 4 people that you're trying to give tasks to, and there is no plan for where things plug in and where they patch to, it is going to be chaos. And that load-in will take 5 times longer than it needs to. Because everyone's just gonna be winging it, and no one's gonna know where anything is connected. So you gotta take that time, figure it out beforehand, so that when you walk in that room, you know exactly, you already know. You know which wall plates you're going into, you know how long the cables need to be, you know which adapters you need. You've already pulled them from the shop because you did the patch plot and you figured it out. Okay? It's going to feel like, wow, this is a lot of work, but it is work you will have to do. And it's way better to do it before the load-in than during the load-in. All right? But for now, I don't need you to figure it out. I just need you to recreate this spreadsheet. Okay? And teach yourself how Excel works. Or if you are determined, you can try to figure out how to do this in Google Sheets. Your mileage may vary, just heads up. So I would recommend Excel, but that's fine. I really don't care as long as the end result looks the way it needs to look and is correct. Okay? So that is it. Yes?
It came up whenever Courtney and I were just working on an NO4.
Yes.
Which ends are socket or which ones are pin? No?
They don't work that way.
Okay.
So the whole point of NL4 is that you never see the contacts, because that's high voltage and high current, potentially, on those. And you don't ever want that live cable to have exposed contacts. And so it's a connector design that purposely avoids that concept of pin and socket, because it just doesn't work that way. So instead, it's best to just use the model number for the connector. And I can show you where you look that up. So you go to Neutrik.us. Neutrik is the website that makes all the connectors. And NL4 is one of a type of connector called a speak-on. Now, a lot of people just use the term, oh, it's a speak-on. It's like, well, okay, there's like 50 different speak-on connectors. Which one are we talking about? Okay? We need to be specific here. So there are cable connectors, and there are, well, I call them plate connectors, or wall plate connectors, or panel connectors, or something I call them. But they're calling them chassis connectors. But here's all the different kind of cable connectors. Most of the ones you're going to see in our shop are the FC series. So, and there's NL4, there's NL8. So it's NL4FC for the cable connector. And then the panel connector, most of the ones you're going to see around here are going to be the NL4, let's see. It wasn't NL4MP. Oh, there it is. NL4MP. NL4MP. That particular one is discontinued. I don't know what the replacement is, but it's got solder connectors. NL4MP. So you mostly solder these. It's not like a PCB mount or something. But NL4MP or whatever. Oh, the successor is NL4MPXX. This one. So that's the new version. Looks like they had to tweak it to get some sort of IEC compliance certification for it. So whichever one it is, just say that. You know, go look at it and be like, is that an NL4MP or is it an NL4MPXX? Which is it? And you just put that in your patch plot. It's an NL4MP or an NL4FC. Or it is like if you're in Performance Place in the Friedman Catawba amp room, the patch cables have this on one end. It's called an NLT4, an NLT4MXX. So it's just an NLT4MXX. And that's what you put in the cell. Because you gotta, you know, someday you're gonna have to buy connectors. And if you just, you know, do it based on the picture, it's a little bit, it's harder to make that mistake these days because mostly we order online and you can see what you're ordering. But this was not that long ago where you did this all over the phone and you would tell somebody, hey, give me 50 NL4 connectors. Or, yeah, or you could just say, I need Speakon connectors. I need 40 Speakon connectors. I mean, if that's all you tell them, like, you have no idea what they're actually going to give you. So it's way better to just get used to using the model numbers. Then you know for sure that you're talking about the same thing. And that way you can always get the right model number from Neutrik website. And then you can go to whatever place you're buying these from and just put that model number in and it'll come up. And you'll know you're getting the right thing. Because there are tons of combinations of NL4 Speakons. I mean, there's NL8s, there's NL2s, there's the NLTs. There's just like there's so many different things. So that's my advice. It's a totally different kind of connector. Other questions? All right. Well, you may get to work on this then.